So what has happened over the last 1,000 years? This is very complicated. This is called the hockey stick. And that's because it looks, here's the blade of the hockey stick, and there's the stick. But as you can see, this stick has a very, very weighty handle. Is the last 150 years just an accident of nature? Well, the fingerprints say no. But if you look over 1,000 years, and all of these are different techniques to reconstruct the temperature over 1,000 years. Why can't we use thermometers? Because they didn't exist before 1600. And because they were not globally widespread until at least 1863. Therefore, you use tree rings and other so-called proxies. Many different answers. Every single answer, no matter what you hear from the coal industry, shows that the last 40 years is above that of the last 1,000, and probably more than that. So this is, again, not proof, but another piece of evidence that is used to the belief that the fingerprint of human activities is practically defined. All right, now let's talk about impacts. Because when we policy sequence, we need to discuss how we deal with the impacts as well as reduce them. So I am not a very good PowerPoint artist. My students laughed at me when I told them that was a 747. So my wife and I went to Greenland last year, and this is about 7 degrees latitude. It's above the Arctic Circle. And this is the giant ice sheet. And the sides are melting, and the top is building snow. So that is outside the window. Why would there be more snow in a warming world? Because the top of the ice sheet is so cold that even when it warms up, the atmosphere holds more moisture when it's warm. That's the law of physical chemistry. So if it's still below freezing, when it snows, there'll be more snow. That reduces sea level because it's building snow on the top of Greenland. Also the top of Antarctica. But the sides of Antarctica are much warmer, and when you increase temperature a few degrees, they melt. And the question we'll address in a minute is who wins? The building of snow or the melting of snow? Let's take a quick look at this. This is competing explanations. Remember I said we had competing explanations. That is a telephoto lens I took. Do you know what these blue are? Those are big meltwater lakes up there on the ice sheet. And these little lines are the rivers that drain them. They're really quite spectacular. Here's one lake. Now where does that water go? It's a moonlight. That's the word for it. And the question we have is, does it create a tipping point, which I'll explain. That is a movement. The water goes down. Why does that matter? Because the bottom of the ice is very cold. The water is at freezing. If it reaches the bottom, it will melt water. If you start to melt water, the ice starts to slip faster. Take your hand and go like that. Feel warm? Once it starts to move quickly, it melts more ice, making it move faster, and then you go irreversibly, you can't stop it, to losing the ice sheet. A tipping point would be the amount of warming it takes to irreversibly create many meters of sea level rise. An example is, and I'll stop what you care. An example is if you have your children going to school in a bus, and it's hills. The bus gets to the top of the hill, it starts going down. That's a tipping point, gravity. Now, we don't worry because we assume that the driver is well trained and the bus has brakes. However, in the planet, there is no driver, and we don't know if it has brakes. So the problem is, are there tipping points which, if we allow this experiment on the Earth to continue, we will have irreversible change, like many meters of sea level rise, species extinction, 1,000 years of increased hurricane intensities that we cannot stop. And that's where the debate is very controversial. Please.
刚才的教授特别提到这个例子啊，这个是格陵兰的那个叫冰河湖穴，就是当他刚刚特别有讲到，前面在 competing 的 explanation 啊，这两个是互相竞争的这种解释，就是因为当暖化的时候啊，这个蒸发量是会增加，所以事实上雪会下的更多，雪下的更多，海平面上是会下降，也会积在楼上。那另外就是它的溶冰量其实很大，所以会让海平面上升。那这里面特别要强调是说，那个引爆点的问题，就是如果说，这个冰河湖穴越来越多，这个水它流到很下面的冰层，它会把下面的冰也融化掉，所以会变成整片的大块冰崩到海里面去，它就会造成这个东西是现在一般人比较担心的，会引爆了以后，而且会让海平面在短时间增加几公尺，而不是几十公分。那他有特别提到说这个引爆点就是说。这样子一直这样下去，会不会到有天就没有办法变成一个 irreversible， 变成一个不可逆的反应，我们就往这个方向去啊？特别举个例子说，如果说我们一个 school bus 一个学校的巴士载着小朋友，这上下坡走，如果上了坡以后又下来，我们当然会假设说那个司机他是受过良好训练的，而且呢刹车可以踩，但是在自然界里面没有这个司机，也没有这个刹车。所以我们会知道说接下来会发生什么事，那个不可逆，不可逆。
Thank you. So how can we tell whether the water is getting to the bottom or not? Competing explanations. One group says it refreezes before it gets to the bottom. Another group says it gets to the bottom. This scientific uncertainty is absolutely crucial for planet Earth because it determines our sea level for the next 1,000 years. So how can we try to answer this question soon? So NASA, the space agency, has a high technology solution that they came up with, and that's their high technology solution, the rubber ducker. They tried to put cameras, they never reached the bottom, they got stuck. All they know is the water keeps going down, nobody knows how far. So they put ducks in. And if you look at the back of the duck, you see it has a phone number. So if somebody finds one, you're supposed to call NASA and tell them that this is a tipping point detector. So I asked the man who's doing it, have you done any better? He said, yes. He said, this year we have smart ducks. What's a smart duck? It has GPS, so we'll know where it is. And it sounds silly, but it may actually be the cheapest and fastest way to figure out. The problem is, it may take 25 years for it to get down there. There may be a tipping point, and it will be too late to prevent if we wait. If we don't wait, then we have to take action. Back again, it's a political choice. How can you figure it out? Well, this picture shows you the orange is where Greenland has been melting on the sides, and the white where it has been building up on the top in the last 30 years. 30 years is not a long time. Competing explanations. School A, it's natural variability. School B, it's global warming. Those are the two that we have. How can we tell? Well, if you had a 1,000-year record of melt here, you could see if the present melt is unusual. Well, there is no record. People have only been observing it for a short period of time. But these red dots are very important because this was the way that glaciologists could solve the problem, or at least give us a much better idea of the preponderance of evidence. Oops, back up. Sorry. I thought I had another slide. What these red dots represent is pipes in the ice. Every year it snows. Then the summer comes, it stops, or it doesn't snow much. Then another one. You can count down 1,000 years. If this were a natural variability, you would find melt periods in the past 1,000 years. The red dot says first recorded melt. That means at this elevation, it has not melted in the last 1,000 years. that makes me believe it is much more likely that this is a global warming signal than a natural variability. And therefore, we have much stronger need for policy action than we used to think, even before the rubber ducks got out. That's me.
这边有重点啊，上面那个白色的那个是过去几十年来的雪的堆积啊，那个粉红色啊，就粉橘色那个地方是观察到的融冰。那到底是就是两个 competing 的两个在竞争的解释，一个是说是自然的循环，另外一个是全球暖化。那他就讲到说，那个红色的点啊，是大概去记录过去到现在的融冰或积雪的记录，就发现说那些点是说在大概是过去1000年以来吧，或几千年以来第一次那个冰第一次融掉，所以呢，这个证据让他相信说这个不是自然的循环，而是全球暖化。
Thank you. This picture is to remind people that what happens to the sea level has very high economic consequences. The islands of Hawaii, where I was a couple of months ago giving lectures on this and discussing with the people and the government. This is, of course, the famous Waikiki Beach, and nature was very cooperative with the rainbow. And this one strip of beach is worth $1 billion. If the sea level rose ½ a meter, it would be in trouble. If you put a seawall out here, I don't think it would be a very popular resort. And therefore, these consequences, even if they are 50 or 100 years away, when they are inevitable and inexorable, have current and present value for our view of the sustainability of the Earth. And those values will be debated with those people who see the world as short-term cash flow transactions and return on investment. And that debate is, of course, what we will hear in Copenhagen over and over again. Very quickly on that, or yeah, I think we should probably.
就是这边如果说这个海平面上升了50公分的话，在这个地方的价值都没有了。
They're no longer existing because there's the town of New Orleans. That's Lake Pontchartrain. And the United States was very smug. It thought it was relatively invulnerable to problems of global warming until a few years ago. So here's New Orleans. This lake is actually the ocean because it's open to sea level. This is the Mississippi River. And the town is right in the middle, below sea level, protected by 2 giant dikes or levees, in a way just like up in beyond. And everybody lived comfortably thinking that these devices would protect them. Meanwhile, scientists were saying they were too weak. They would not protect them against a severe storm. And with climate change, warming the oceans, with the possibility of increasing how strong the storm is, they would be even less protected. However, it would have cost $10 billion to fix them. And the government chose instead to save the money and take the chance. So what happened, we all know. Here is the Mississippi River. This is the ocean. The dike is very strong, so the Mississippi River was in pretty good condition. The river was not going to go over the top. But look at this. It was designed for 11-foot surge. Notice already there's a foot sea level rise. That's partly due to global climate change, partly due to pumping of oil, making the land go down. So the combination is that the height of the dike was lower than you could sustain in a Category 4 hurricane. 4 is a big hurricane. And a 5 would take it out. This was the city waiting to die, with or without global warming. What global warming does is increases the probability. And they have been told many times, and always took the short-term, cheap solution. So what do we know about the oceans? I apologize for this complicated picture. This is Western Pacific, North Atlantic Ocean. This is summer. ocean surface temperature. This is global warming. It's happening in the oceans too. I laugh when I hear somebody say, oh, it's just cities. Cities that are warming, not the rest of the world, called the Earth to be island. Well, how come the middle of the ocean is warming up with these just the cities? And when you take a look at the various curves of upward warming, theory tells you that if the ocean water is warmer, the amount of evaporation of water vapor is stronger. This is completely non-controversial. Everybody agrees that in warm water evaporates faster. When the water condenses in the clouds into rain, it releases the heat from the evaporation and drives the circulation of the storm. So theoretically, warmer water is stronger typhoons and hurricanes. That's why typhoons occur in the summer and fall, not the winter and spring, because the ocean is warmer. So the question is, can global warming add extra strength to hurricanes? Very controversial, because ocean temperature is one factor. There is how deep the ocean is mixed, how high the stratosphere is, what happens to the winds above. All these factors, nobody knows whether they favor stronger or weaker storms from global warming. But the one thing that's certain, and I'll let you explain this, the one thing that's certain is sometimes all these other factors will be aligned for a very strong storm. When that happens, warmer oceans must make the hurricane more intense by thermodynamics.
有点复杂啊，意思是说，当海平面的海温上升的时候，大家都知道它会蒸发量会更高，蒸发量更高，到天空之后有更多水汽，当凝结成雨滴降下来的时候，它又把一些余热把它释放出来，就会变成一个机器驱动的整个台风啊，或是飓风等等的。但他说有很多其他的因素也一起考量啊。但是当这所有的因素都放在一起的时候，这个促使蒸发量上升这个因素它还是比较重要的。大致上说，它里面还有很多很复杂的，就像时间的关系啊，我们在这里也不细加解释。
This picture shows what happened to hurricanes in the last 30 years. And you notice that there's not much change in the average speeds. There's, in fact, a slight decrease in the weaker storms, Category 1 and 2. Monorail was a 2. When I say weaker, I'm talking only about the strength of the wind speed. If the storm is very wide and moves very slowly, it can be even more dangerous than big wind speed that moves quickly. We'll talk about that soon. Notice the big increases in the strongest storms. So here, nature is cooperating with theory. But it's a very short-term record. The data is not good. Nobody would claim that this is proven beyond a reasonable doubt. But the preponderance of evidence suggests that there already is a noticeable change in the top intensity hurricanes from warmer oceans. But that argument will continue. IPCC said that it was likely in the future and more likely than not now. So for New Orleans, greater than Category 3 tropical cyclone, we had low adaptive capacity because the seawall was too low. Vulnerability, that is, whether you're at risk, whether it's in New Orleans or here or anywhere else, is an emergent property. That means a combination of the social and the natural system as it works together, very complicated scientific problem, influenced by risk management decisions. Risk management decisions include how big is the seawall and how much greenhouse gas are you going to allow into the atmosphere. Risk, which we scientists do, is what can happen, multiplied times the probability it can happen. Risk management is should you take the chance. How do you spend your money? And therefore, risk management and environmental hazards contributed to the disaster in New Orleans. Do you want to very briefly read that? Sorry.
这里面讲到一个比较重要的观念是这个 vulnerability 这个脆弱度，特别Snyder教授有提到说，那是一个非常复杂的自然的社会现象的结果。因为这个东西也会影响受到风险管理的决策所影响。比方说，我们到底要决定这个体要盖得多高，或者说允许多少的温室气体排放到大气中。所以这整件事情它有跟环境灾害之间有影响。这个观念大概是他接下来会特别谈到的，因为他接下来已经开始谈到调试能力的事情。
Thank you. Now let me get closer to home for you. You all know about that. What made this storm interesting was not so much how strong its wind speed was. It was a strong storm. It was a Category 2, but very long. It was a very wide storm. Therefore, it had a great deal of rain, and it did not move quickly. And as Mr. Liu said in the beginning, this was record rainfall. And unfortunately, when you have climate change, records happen much more often than when you do not. That does not prove it, but it certainly is consistent with the theory. So let me take you on a photo essay that Professor Liu took me on, and I should thank him for doing all the hard work of arranging my visit at this spot and being just a wonderful host in the country. And it has been my great pleasure, and I'll show you our trip yesterday on the train down here from Taipei. So I thought this was a very clean, nice railroad station, and then I noticed that. What is that? And he explained to me, taking the train generates much less carbon dioxide than driving. And what they were doing is saying to the polar bears, thank you for being an efficient consumer. They also, I think, had the penguins thanking you too. It was very good. Now we get more serious when we go to the Aboriginal town of Liyi, up on the upper Lindian River yesterday. And thanks to Professor Ding being our guide, who was a very wonderful guide to us, and also to a Japanese group, he was running back and forth with different languages trying to explain what happened. And this group of workers, it was a very strange, emotionally strange event, because we all knew that the new typhoon is just creeping. And it's very important that the one thing it does not do, it's not strong. It does not stop and sit there and pump wind from the southeast for 3 days. That would not be good. So they have been working very, very diligently to make a temporary dock. You had, the rain was coming, and you had this eerie sense that you were in the day before a battle or a war. People were working so hard. This was adaptation in action. Of course, adaptation is the only thing you can do in this much time. Mitigation takes decades, but should have started decades ago, and it would be easier now when I had quickly.
这是昨天我们去来义乡嘛，这是来义乡在里面机上有个地方看到，因为今天台风来嘛，所以当年在赶工赶出有临时的地方出来。但是意思是说，这个其实就是 adaptation， 就是调试。我们面对一个灾难来的时候，我们能做的调试都是很快我们可以马上做的哦。但是这个 mitigation 缓解这个事情，可能它的效果要在数十年之后才会出来。但是现在也要做，因为每天都在算时间嘛，所以现在也要开始做。他就用这个东西来比喻调试还有缓解这两件事情。
Okay, next. So this cement house was just completely removed from its foundation up there in this town, and it was very strange. There were no people in the town. The police had removed them, and it wasn't because the river was necessarily going to flood. It's because the ground is very wet, and if you get heavy rain with very steep slopes behind you, you can get mudslide and slide you off into that river, which would be deadly. So there they were working away and trying as fast as possible to get the river to be safer in case this typhoon stops and does it again. It's not as big as the other one, so I doubt it will be as bad. But you don't want it to happen right at the same time when the ground is melting. Now this is at the mouth of the Lindian River in the town, and that used to be a railroad bridge. And why did the flood destroy the bridge? Well, for two reasons. First of all, it was too low. It was not built high enough. And second of all, it was built, I think, 8 years ago, Japanese occupation. As a result, with all the groundwater pumping, it sunk. So the two factors, the negative synergism, occurred. Now, the rebuilding is much higher. That is an adaptation. So the adaptation is to go higher. The important thing, and this is the most important thing to remember about adaptation, it is much cheaper if you do it before you build it than if you try to fix it after you build it or after it breaks.
实在是要特别讲到这是那个林业气象会会知道，林业淹水的原因是因为原来那个铁桥很低嘛，它的两个负面协同效应，一个是当时建的很久以前当时建的，另外一个是那个地层下陷嘛，所以下陷比较高，它这个典型的打培群的调试，但是调试有个重点，当事情发生之前，你先做好它省很多力气，省很多钱。但如果说是事情已经发生了，或是已经发生了很严重事情以后，你再来做的话，它可能要花2倍以上钱，或者效果变得不好。那这边特别谈到调试的时间点的问题。
And this was down in the town, and you can see the mud that came over the seawall, and the wall broke from that flood. And that beetle nut tree should be standing up here. But there it is. That's how high the mud is. You can see the house is covered. And it's very expensive to fix. It's much cheaper to prevent. However, in the process of preventing, you do affect certain industries that need to become part of this and need to be helped. But I'll get to that. So I need to finish in the next 15 minutes, and I want to get there. This is not just a problem in Taiwan. This is Hurricane Ike in September of last year. A very, very similar storm to Monaco. It was a very high category 2, so it was not like Katrina, which was a 5, and then came down to a 3 when it hit New Orleans. But it was very high, very, very high. And the trouble with humans is that we sometimes become arrogant and think that we can control nature. So the town of Galveston in Texas, which was destroyed in 1908, and it was destroyed again in 2008 when they did not believe that was possible. How did this happen? Because Galveston built this giant seawall. This driver is so confident in the hurricane, he's driving on the seawall. If the water came over the wall, he would be killed. It was not. The seawall was big enough to protect the town from the storm surge. But they forgot something. When you warm the oceans, storms don't just get bigger by strength of wind. They can get bigger by size of storm. And the storm was so big that the surge went behind the seawall, and instead of being one giant break, came in the back way and filled up the back way, called Galveston.
OK， 这个是他特别挑说海水很高，海水非常高，所以那个 surge 这个涌浪不会从上面打过来，但是因为那个 hurricane 那个飓风它的整个范围变大了以后啊，它就造成一些其他的效应，结果那个水从旁边这样转起来，